resilience and reliability benefits are during what we call gray sky events when there is a hurricane or an outage caused by some kind of an issue. A lot of these are basically what we call kind of blue sky days where you're able to use the battery, the solar, generator, anything else that's part of the microgrid on a daily basis when there's not an event happening to recoup the investment cost and to be able to get value from it. So I think that's one distinction that I want to say of, what we think about
Sure.
microgrids, rather than just kind of an emergency backup generator. You can think about this as a holistic system that actually provides value over the course of the year.
Are you speeding the energy transition? Here at the Clean Power Hour, our host Tim Montague bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. Hey guys, are you a residential solar installer doing light commercial but wanting to scale into large C&I solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much. Today on the Clean Power Hour, scaling utility microgrids. My guest today is Martin Szczepanik. He is the Director of Energy and Resources at a global consultancy called Baringa. Welcome to the show, Martin.
Thank you, Tim. Really looking forward to being here and talking about microgrids.
Me too. I
Mhm.
love microgrids. Today they're a rare commodity, whether it's at the micro or nano scale, like building scale
Mhm.
or community scale. They're just not very common, but they're
Mhm.
super useful. And you guys have a great frame in this recently released white paper that we're going to drill down on, that utilities should treat microgrids as a strategic network asset rather than one-off pilots.
Mhm.
And plenty of pilot projects are being done. We have one here in my hometown of Champaign, Illinois, that Ameren rolled out. It's got a wind turbine, a solar array, a battery, and a generator, a diesel or natural gas generator. I'm not sure which. And they see it as a pilot, though. They're studying how the microgrid works when they go into isolation mode and
Mhm.
looking at how the battery provides services. And we're going to geek out on the value stack of microgrids because you have a wonderful graphic, and this is quite the stack. So we're going to spend quite a bit of time on that. But Martin, for our listeners, paint a little picture about yourself. How did you
Mhm.
come to the energy world?
Yeah, no, thank you very much, Tim. Yeah, really looking forward to talking a bit more about the value stack and microgrids. So I've been working in the energy industry for about 11 years now. Prior to that, I actually was in accounting and audit. So I really have an affinity for building financial models, building Excel models, and that's part of the reason why I really like the value stack framework. And a little bit of it is leave no stone unturned and just think about all the value that an asset like a microgrid can bring. So I've been working in the industry for about 11 years, pretty much across the entire energy value chain. So one of my first clients back when I was at PwC was a company called SolarCity, which you might be very familiar with, before they got acquired by Tesla. Moved a bit more into the compliance and system implementation world. So did a little bit of work like that with some utilities on the West Coast when I was there. And then probably about 6 or 7 years ago, I really focused more on, I would call kind of general utility strategy, where the importance of building a business case, both thinking qualitatively where a utility should invest, and then also backing that up with financial modeling, backing that up with quantitative assessments for why a utility should invest in a particular area, both in terms of helping out their customers, and then also following regulation, including all the state regulation that we've seen of achieving net zero, of making the grid more flexible. So I've done a bit of work with utilities, done quite a bit of work with also renewable energy developers. And I think the really interesting thing to me about microgrids is that it intersects a bit of both. And the way that I say that is, if you think about what a microgrid actually is, it is both an asset for reliability and resilience purposes. So you have a microgrid, and let's just say that it's a combination of solar, batteries, and a diesel generator. You're able to, with the right infrastructure, the right hardware, the right software, you're able to isolate yourself from the grid, or from a portion of the grid, if the grid has a bigger outage. So it's both a reliability and a resilience resource. And then if you think about the savings that you can make on it, so with a microgrid, if you have solar on the roof, or a separate solar array, that also is zero marginal cost power that you can use to offset the wholesale power price that you would pay from either from the utility if it's a behind the meter microgrid, or from the ISO market if you're in a vertically integrated market. So really, my interest has really focused on those areas where you can get a lot of value out of a single asset. And one thing that we've been repeating to a lot of our clients is you can treat a microgrid as a Swiss Army knife that's able to deliver a lot of sources of value in very particular, in different particular situations, different things that are going on. And just one thing I want to mention, and one of the reasons why this microgrid topic is growing and is so big, is if you think about all the trends that are going on right now. So we've got increases in power prices, and those are both from a wholesale perspective as well as a retail perspective. Retail being the distribution infrastructure that's being built, and that's what the distribution utility portion of a bill is. With the wholesale prices, that's with the repeal of the Inflation Reduction Act. We are expecting to see power prices go up pretty much across the board for the entire country.
Already
There's
have.
this yeah, exactly. So there's this cost element to why microgrids are appealing, because you can basically insulate yourself to some extent from those increases in costs. So that's one trend. The other trend that we're seeing is extreme weather events, and we've seen, just recently, Hurricane Melissa that rolled through the Caribbean, wide-scale power outages, wide-scale destruction of the system, and a lot of companies either don't want to wait for the utility to build that infrastructure for them, to rebuild the poles, the wires, the cables, the transmission assets. So a lot of people are taking that into their own hands, including both communities and individual customers themselves. So we've got that trend. And then we also have this ongoing trend of electrification with data center build out, with
Right.
conversion to heat pumps, conversion to electrification. So
It is a convergence. It's a perfect
Yeah.
storm of storms. And I was talking about this at Tennessee recently. I gave a short talk on microgrids. The statistic that blew my mind, Martin, around storms was that billion-dollar plus natural disaster storms used to happen in the U.S. approximately once every 90 days in as recently as the 1980s, which is now 40 years ago. Okay, but
Yeah.
my lifetime, and now that statistic is every 19 days.
Mm-hmm.
So these storms are really becoming more frequent. It's a real thing. Math doesn't lie.
Yep.
Like, it's a thing. You can call it a green scam all you want, but it's just the reality that we're in. And so
Mm-hmm.
resiliency is ticking up in importance, right? Because
Yeah,
it's no
of course.
fun when the lights go out and if the HVAC isn't working and it's freezing cold or boiling hot, one or the other, right? It's just no fun. And microgrids give us this ability. And I've been covering this topic now extensively. And I would encourage our listeners to check out cleanpowerhour.com. And for example, AJ Perkins, who's talking about residential community scale microgrids in Hawaii, where you put residential batteries in a whole fleet of homes and then use that battery as a VPP, virtual power plant, for other grid services, but also for local resiliency when there's a storm, fire, flood, drought, whatever. And then, of course, this AI explosion, it's so real. You know, I was in Nashville, but I gave the example of Colossus in Memphis that XAI, Elon Musk's company, has built there. And, you know, these data centers are now on the scale of 1 to 10 gigawatts.
Yeah.
Very big, like a big solar farm. Some of the biggest solar farms in the U.S. are 1 gigawatt solar farms now. A nuclear power plant is traditionally 1, 2, sometimes 3 gigawatts. And now these data centers are 10 and maybe 15 gigawatts. They're really big loads.
Yeah.
And Peter Kelly Detweiler commented recently on the show that there was an event in Virginia a couple years ago now where the data center went down and isolated from the grid, and that was a major shock to the grid. So there's a double edge there, that they're a big load, but they're also a big kind of a quake on the grid when they go offline.
Yeah.
How does the grid operator respond to that? And then one last thing I want to put a pin in for our listeners, and that is that the Clean Coalition, Craig Lewis specifically in California, has really made it clear that this is good for utilities because they want to build T&D, transmission and distribution. That's part of their business model. They have a cost plus business model. They're incentivized to build infrastructure, but they can do that by building microgrids at the community scale. You build a big solar farm, a big battery, you can add wind if you want, and then the switchgear, smart switchgear, and then you have a community scale asset. The utility gets their happy work, and then the community gets resiliency, which you don't get from traditional T&D.
Yeah.
So what else should our listeners know while we set the table here? And then let's dive into the microgrid value stack, because that is a wonderful conversation that every energy professional needs to know how to discuss.
Yeah, Tim, I think you're spot on with all of that. I think what would be helpful is if I just talk a little bit about an example of when I think of an obvious example of where a utility microgrid makes a lot of sense, and I think it'll help visualize for the listeners a little bit. So if you think about there's certain communities, and let's just call them rural communities, where you have a substation. So a substation is where you get high voltage power coming from transmission lines that gets stepped down, and then that gets transmitted through a distribution line. You have a lot of places in the country, especially in more rural areas, where you have a very, very long line and a very long cable between that substation and then a community that is served at the end of that.
Mm-hmm.
And then what happens is, if you think about a storm, think about a hurricane, think about wind, right? Anytime any one of those poles gets knocked over between that substation, so the point of origin of that power, and that resulting neighborhood, that neighborhood is out of power, that community is out of power. So it could happen right next to the substation, or it could be the last pole right before the community. And what happens is you just have so many opportunities for an outage to occur on that particular line, where if you actually go through and do the analysis, what you could do as a utility is you can go in and replace all of those wooden poles with undergrounding, for example, which is incredibly expensive. So think about, digging a trench for 15 to 20 miles, removing all the poles, removing all the transformers, removing all the equipment, putting all that equipment underground. Or what you can do is you can focus on the community that's at the end of the line, add battery storage, add solar, add potentially a diesel generator if you think that there's going to be
Sure.
longer duration outages. And then what happens is you don't have to rebuild that full entire 20-mile line. You can basically just invest in that microgrid that's at that end of the community. And by the way, you could also take a look at other parts of what we call the value stack in that case, which is, all right, now that community has solar that they didn't before. So the power that they on a daily basis, when there's not an outage event happening, on a daily basis, they can get the free power, the zero marginal cost power from solar. So that offsets cost for the community. So that's one point. You have a generation source that's right nearby the community. So, for example, if you think that there's going to be electrification, if you think there's going to be new load growth in that particular area, you can use some of the generation that you've built in that particular microgrid community to offset that. And so, on top of all these reliability and resilience benefits, which, if you're in a utility mindset, that's kind of the number one number that you're aiming to target. You want to reduce outages as much as possible with the constraint that the regulators apply to you, which is doing it in the most cost-effective way, or the way that actually brings the most value for each dollar of cost. You're not going to be able to do that unless you think through all the different sources of value. But I think as we've been doing this, and we've been doing this work for a couple of utilities at this point, those tend to be the most obvious microgrid examples. Is you got that long line, lots of outages at the end of it, but without doing a value stack analysis, you really miss the opportunities to identify where a microgrid on your system can be optimal. So one thing that we just encourage everyone to do is take a look at the value stack. And I know we're going to get into it, but take a look at the value stack, calculate that full value of what a microgrid can be, and then how does that compare to other options that you have, including rebuilding the substation, undergrounding a full line, building a new gas peaker plant if you're a vertically integrated utility, but looking at different options and looking at how they actually stack up against one another.
Yeah. I mean, I guess it begs the question, Martin, has anyone done like a global analysis just of the U.S. grid and said, okay, here's the state of the grid today. We know that it's good, but not great. And we know that the load is increasing dramatically, right?
Yeah.
Just a fact, right? And, there's lots of friction in that getting more power onto the grid. Developers want to put more power plants on the grid. I think there's 2 terawatts of renewable energy projects in the queue. And I just heard yesterday that FERC has been, ordered to analyze the interconnection process for data centers to potentially expedite their interconnection because it is a national security issue. We have to keep the compute growing exponentially in order to grow the superintelligence, even though we don't know what's going to emerge potentially at the end of that journey. But both Baringa and myself are also in this space of AI consulting, because you have to also bring this intelligence, this electricity, I call it, right? Superintelligence and AI is just like electricity for your business. It's an accelerant. It's going to help you go further faster. And if you don't have it, you're going to get left in the dust and perhaps get, obsoleted. But I wonder if anyone has done a global analysis. And honestly, this is a good problem for an AI to solve. Like, the grid is a big, some say the most complicated machine that humans have built. And it's just kind of dumb today, right? Like you said, if one pole goes down, it can strand many customers on that line. And that's just not a good scenario, especially understanding that these big storms are absolutely going to happen. Nowhere is safe. I was thinking of moving to Asheville, North Carolina in 2022 because it was climate resilient and a cool place and mountains and good climate. And then boom, that hurricane just dumped a massive amount of water on the poor state of North Carolina, right? And it just devastated the community. I dodged a bullet, literally. But nowhere is safe. You think, oh, well, there's, California fires, floods, windstorms. I'm here in the Midwest. Yeah, we have a big fault in southern Illinois known as the Madrid Fault, which is going to cause a big earthquake at some point. But other than that, and we're at the tail end of Tornado Alley, but I have to say it's like pretty safe. It feels pretty safe here, but no, I don't think anywhere is safe in the new climate. So let's get into the stack.
For sure.
And we'll put a link to this white paper in the show notes. The white paper is called From Pilots to Portfolios, Scaling the Rollout of Utility Microgrids. And just a couple pages in, you'll see this wonderful diagram of the microgrid value stack. So let's just go top to bottom. And I'm just going to call out for our listeners what the full stack is, and then we'll go piece by piece. But it's resilience and reliability, distribution capacity deferral, transmission capacity deferral, ancillary services / congestion, energy arbitrage, generation capacity deferral or peak shaving, avoided emissions, and avoided ignition risk. I love this. I am such a geek for this. I don't know if this is a unique framing. As we were saying in the pre-show, I also love IG's Intelligent Generations coining the phrase earn, save, protect. But let's talk about resilience. What does that mean to you?
So very appreciate the question and appreciate the compliments. We're very proud of the value stack. There are other different iterations of it, but we're pretty confident that we've covered most of the value. I know it's impossible to take all of the value together, but I think we've done a pretty good job at it. So first of all, I do want to distinguish. We do use different terminology for what we call resilience and what we call reliability. A lot of times in the industry that is interchangeable, but when we say resilience, we are referring to outages caused by extreme weather events, and those weather events can be from a hurricane knocking a pole over. It can be from a wildfire tearing through and burning down a substation. It can be from a flood that floods a substation, so the transformers no longer work. So when we say resilience, we're really referring to the risk that you have an outage in a particular area of the grid based off of the impact of an extreme weather event. And when we think about that, there's a couple of components to it. So one is, and Tim, this goes back to what you were mentioning before about climate change and the impact of extreme weather, is extreme weather isn't stationary, and we have good climate science now where we can actually project out what that weather is going to look like. And so the issue that we have with a lot of that a lot of utilities are kind of going through right now is that a lot of their historic planning of their system has been done using historic weather years, and basically a retrospective look back of Tim, exactly like what you mentioned, right? Where one Category 5 hurricane happens once every 100 years, right? We just saw a Category 5 with Hurricane Melissa. We just saw multiple Category 5s in a much compressed time frame. So you can't really rely on historic weather years because the climate isn't. Yeah, exactly. So the climate isn't static. So part of this analysis and part of this value stack is what is the probability of extreme weather events happening in the future based off of the non-static nature of climate change. And what we know is, for the most part, floods are going to get worse, hurricanes are going to get worse, fire is going to be a higher risk in certain parts of the country. So what we do is we project out what we think that risk of something like that is actually going to happen, right? So then what we do is we take a look at our existing assets and then on the utility system, and then we see how vulnerable they are to those events happening. So I'll just give you one example. If you have a steel pole versus an old ragged wooden utility pole, for example, the wooden utility pole is much more likely to fall over in a bad gust of wind or a bad hurricane than a steel pole is.
Right.
So it's essentially a cross-reference identifying what the risk of an outage is given the non-stationary nature of climate change, aggregating all that information together. And then what we do from a resilience standpoint, and just going back to how we model microgrids, is depending on the type of event that it is, you might have foresight into it. So for example, if you have a microgrid that has a battery And normally you want to operate that battery up to an 80% state of charge or down to a 20% state of charge in what we call blue sky, kind of normal operating conditions. In our model, and the way that we think about with resilience is if you see a hurricane coming, let's just say that you have 24-hour notice that the hurricane is coming, you can charge up that battery to 100% and then
Right.
wait for it to discharge down. So when we say resilience, all goes back to the fact that we're talking about extreme weather related outages, how they impact your utility system, how they manifest in a risk of an outage happen and how long that outage would happen, right? So
Yeah.
that's kind of the resilience side. Um, Reliability is a little bit different because reliability, we consider that as age and condition driven and not related to an extreme weather event. And the big distinction there is we don't assume when we do our microgrid modeling, we don't assume that you have foresight into a reliability event happening. So reliability event, and this is actually kind of a funny story. So we're doing work with Anaheim Public Utilities in the city of Anaheim. And I think, Tim, I think I actually asked you this before, so you might know the answer to this already. But what is the main cause of outages in Anaheim, California?
Gosh, I know that I got it wrong when I answered it the first time, but I'm going to guess cars.
It's actually balloons from Disney.
Oh, there it is.
Yeah. So it's
Yeah, that's
kids.
not something that I ever would have thought of.
Yeah,
Um,
I can't really put that in my microgrid model, unfortunately. So,
right.
it's
But you make
that's
a
what
good point that this is location specific. The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855 584 7168 to find out more.
correct.
We're going to have to move a little faster through the stack
That's fine.
now,
Yep.
but and I didn't say that you have broken the stack into 3 broader categories: primary benefits, secondary benefits,
Yep.
and additional benefits, which is also a very good frame. And so, for example, on the primary side, it's resilience, distribution capacity, transmission capacity. Let's talk about D and T, maybe
Yep.
together, because they're just different versions of the same thing.
Correct.
One is high
Yep.
voltage, one is low voltage, one is the last mile, one is long distance. They're both very
Yeah.
important, and they're both kind of at capacity and need
Yeah.
upgrading, and they are a bottleneck for the energy transition. But how do microgrids facilitate or augment the value of, or how
Yep.
do microgrids weigh in here?
Yeah. So the way that I would think about that, let's say you have a microgrid with, battery storage, some kind of a dispatchable generation, and you have the ability to isolate from the grid. So let's just assume that those two things happen. Um, the grid as it currently stands is built for peaks. So the amount of the capacity of the system is built based on what you think the peak demand is going to be over the course of a year, over the course of 10 years, over the course of 15 years. And if you do a forecast of your system and say, okay, for this particular part of my system, I expect that peak to exceed the thermal limit of that part of the grid. I have a couple of options. I can either, rebuild that part of the line, upgrade the substation, basically do things to increase what we call the thermal limit of the system in that particular area.
Like
The way that
reconductoring, for example, right?
Correct. Reconductoring, yeah,
Yeah.
exactly. Reconductoring, upgrading, transformers, substations, all that kind of stuff. If you place a microgrid, and if you're in a situation where you have a microgrid on one of those circuits that's expected to exceed demand, if you have the ability during those peak events, which usually don't happen too frequently, if you think about it's a couple days per year in the summer if you're a summer peaking system, couple days per year in the winter if you're a winter peaking system.
Hmm.
If you have the ability to isolate that microgrid where you're not taking power from the grid so that you can basically reduce the total demand on that system so that the utility does not have to make that upgrade that they otherwise would have. That's what we're referring to with transmission and distribution capacity deferral. It's basically saying, okay, if that microgrid didn't exist and you weren't using it in those particular peak events, we would have to spend $5 million to upgrade this line or $10 million to upgrade the substation, but we're offsetting the cost of that by putting in a microgrid instead. So that's what we mean when we say transmission and distribution capacity deferral.
Yeah.
The way you basically look at that and look at when you think you're going to exceed demand, are you able to use the microgrid to offset the need to rebuild, reconductor, upgrade substations, and
Because effectively,
others? Yeah.
what is today just a a load center, let's call it a community at the end of a line, right?
Hmm.
That load center now has generation capacity, it has solar, and it has
Yeah.
storage, right? So it's relieving it's relieving the tension that's on that line, so to speak. All right, let's move on.
Yep. Yep.
Secondary benefits include ancillary services, energy arbitrage, and generation capacity deferral.
Yeah.
What do you say about ancillary services?
Yeah. Ancillary services are a little bit trickier if I'm being completely transparent, but they are if you have a battery, for example, and in the example that you created that you talked about a little bit before, which was when that data center tripped offline,
Hmm.
essentially there was like a voltage spike and the frequency was out of balance. Ancillary services is the capability of an asset to be able to respond to those kinds of events and potentially get compensated for them.
Right.
One thing that I do want to mention that I didn't mention at the top of the call is the Federal Energy Regulatory Commission, known as FERC. A couple years ago, they passed FERC 2x4, which is FERC 2222, essentially an order that requires all of the ISO markets, basically the markets where energy supply is uh, separate from energy delivery, requires those markets to create rules so that distributed energy resources like microgrids, for example, can participate in those markets and actually earn revenue for
Right.
providing services. So in this case, any kind of services, if you have an asset like a battery where you can turn down and turn up very, very quickly, you in those markets where there is a mechanism, you can get paid for those services. So that's and we call that a system-wide benefit because those are usually calculated at the overall system level versus the location specific, which is this part of the circuit, this part of the actual utility distribution system, whereas secondary benefits we're referring to kind of a wider pool.
And it would be primarily the battery that can offer these services, right? Frequency, we're talking
Yeah,
about frequency and voltage regulation.
correct. Yeah, frequency and voltage regulation, yes.
Okay, and then energy arbitrage. I was just talking about Base Power, a
Hmm.
residential batteries service company in Texas that is building a big VPP basically of batteries alone or paired with solar. They don't care. And they lease the battery to the consumer. And
Yep.
it's a air conditioner sized battery that sits next to the air conditioner literally outside their home. And it does energy arbitrage and then resiliency when the grid goes down. But what is energy
Hmm.
arbitrage? I think many people don't quite understand that. And why is it so
Yeah,
valuable?
pretty straightforward, but it's basically charging a battery or charging any sort of device that can consume power and discharge energy at a later time is taking advantage of peaks and troughs in power prices. So you buy power when it's super cheap in a place like California that's in the middle of the day, in the middle of the day in the spring and the fall, where there's a lot of excess solar, but no air conditioning load to take it over. So you can basically buy power at a very, very cheap cost, and then you use it in those higher value times. Either use it to satisfy the load that you have internally within the microgrid boundary, or if you are able to do so, discharge that power back into the grid and then sell that power at a higher cost. So basically, it's just taking advantage of the difference between those two. One thing that I do want to wrap everything around here with is that some of these are benefits, like the resilience and reliability benefits are during what we call gray sky events when there is a hurricane or an outage caused by some kind of an issue. A lot of these are basically what we call kind of blue sky days where you're able to use the battery, the solar, generator, anything else that's part of the microgrid on a daily basis when there's not an event happening to recoup the investment cost and to be able to get value from it. So I think that's one distinction that I want to say of, when we think about
Sure.
microgrids, rather than just kind of an emergency backup generator, you can think about this as a holistic system that actually provides value over the course of the year. But
Yeah, every
just
day, right? Like
uh,
you think of the duck curve in California, and the duck curve is coming to every market. It's just happening
mhm,
a little more slowly in other places, but it's already
yep,
arrived in Texas. And so that cheap solar in the middle of the day, you absorb that into your battery, and then you
yep,
discharge the battery at the end of the day when the sun's going down and the load is actually increasing because people are coming home and turning on their AC and turning on their kitchens. And then again you discharge in you're discharging in the evening, and then you're recharging either from the grid when power's cheap in the middle of the night,
yeah.
or from both the grid and the solar, and bada bing bada boom.
Mhm.
Now it is a benefit for the asset owner typically, right? And I'm just curious, like, how do utilities see this when, as a grid operator, and if they're going to own like a community scale microgrid, how important is energy arbitrage for them?
Yeah, I mean, I still think it's important because if you think about a distribution utility, so just going back to the example where the energy supply is separate from the energy delivery, and then the other nuance here I just want to flag quickly is it is dependent on states, and some states allow utilities to own solar on the distribution network. That's a whole other podcast, I'm sure. But the you as a utility, you still have the obligation to serve your customers with power. And then the way that you do that is you buy power from the wholesale market, so directly from the ISO, or you have a power purchase agreement with a specific power plant. You then take delivery of that power and then deliver it on to your customers, and then pass the cost through basically. So in this case, if you have on-site solar with this microgrid, and let's just say that it's owned, operated, managed by the utility, you're basically able to offset that power that you otherwise would have purchased from the ISO or from a PPA contract. You're able to basically offset that and sell the power directly to your consumers from the solar that's on that distribution network. So that's a benefit. The other benefit that I would say is if you think about a microgrid that has a solar and a battery system, the solar helps extend how long you can withstand an outage for. So if you have only the battery, you charge that battery up from grid power, you have an outage, you discharge that battery down to zero. If it's a long enough outage, you don't have any more juice left. If you do have solar, you can incrementally recharge that battery so that maybe that 4 hour battery becomes a 5 or 6 hour battery to help you get through a longer outage. So that's another way that part of that value stack can be monetized as well.
All right, generation capacity deferral. It's very analogous actually to energy arbitrage,
Hmm.
right? What you want to add? Anything, any nuance on that piece of the stack?
The only nuance that I would add here is that most ISO markets outside of, I believe, Texas and the Southwest Power Pool, they they put a value both on energy that is sold, and they also put a value on the ability to dispatch a power plant on demand. So if your microgrid has a battery, or if it has a generator of some sort where you can essentially turn it on, turn it off, versus solar, which is intermittent and reliant on the sun shining. In those cases, similar to what we just mentioned with the utility not having to pay a PPA or not having to pay for the energy, they can also offset the cost of buying what's called firm capacity from the market, which is, I have a megawatt that's allocated to me, that can be turned on or off at any point in time, based off of my direction and based off of my input. You either pay a separate third party to do that as a utility, but if you have that 1 megawatt within the boundary of your microgrid, then you don't have to pay that 1 megawatt to the market or to a separate third party provider. So it's basically the price of having firm dispatchable capacity that you can offset.
Yeah, like avoiding turning on a peaker plant, right? A gas peaker plant that runs 10 or 20% of the time, the power from that peaker plant is going to be very expensive. And a battery in the long run now, I mean, that's one of the trends that we see is you can replace a peaker with solar, wind, and batteries. And you get cheaper firm power and avoid the pollution that you would have from a gas-powered peaker plant. All right. That brings us to avoided emissions. We have to remember that these legacy power plants, fossil power plants, whether they're natural gas or coal, they have real emissions, CO2, particulate matter, stuff that actually kills humans and other things. And it also causes climate change, right? We're at 430 ppm in the atmosphere, people. I used to say 420. We're already at 430. It's going up 1 ppm a year. We're going to 450. And so avoiding emissions has multiple benefits, but one of the tricky things is putting a value on this, I guess, because it's an externalization that we just kind of accept, right? And we let the power plant operators basically use the sky as a dump for free.
Yep. Yeah. Very, very good point. And I will agree with you that there's not much of a consensus of what the social cost of carbon is, or you ask 5 different people, they're going to give you five different answers. There's a couple of ways that we can monetize this, or when we do talk to our clients, there's a few ways that we ascribe a value to the social cost of carbon or to avoided emissions. One is we use literature like, I don't think it's under the current EPA, but under the previous EPA, they did have a social cost of carbon study where they actually create a curve based off of how many tons of CO2, based off of $1 per ton of CO2. So you can essentially look at your microgrid's operation. Is it, number one, is it offsetting emissions that you'd get from the grid? And then we calculate the difference of those emissions and then multiply it by the social cost of carbon from the EPA. There's also state-specific programs called state renewable energy credits, where for every megawatt hour that you generate of renewable energy from like a solar array, for example, you can get paid for that, and that's more of a direct monetization. So sometimes we use that. The other thing that I do want to mention, Tim, and you did talk about how there are particulate emissions that are not necessarily climate emissions, so not necessarily contributing to climate change, but they do have other negative externalities in local places. We could also just take a look at that and look at the avoided emissions of doing something like that. And just one anecdote for that is we were looking at a project where we would be replacing diesel generators in a very unreliable grid with solar and batteries, and then looking at when you do have those outage events, how much particulate matter are you reducing based off of using solar and batteries instead of turning on the diesel generators, especially in the part of the grids that we were looking at were like heavily urbanized environments where there were a lot of people all together in one place without that. So like there's a lot of different pieces of literature around what the social cost of carbon is. I don't think the value is zero. So you do have to use some sort of
absolutely
some
not
sort of proxy for this. And a lot of times the dollar figure that we use, especially if we're working with a utility, that does have decarbonization mandates. A lot of times the state will actually ascribe a value to use for calculations such as this.
Yeah, I mean, the whole RPS movement in the U.S. is about removing carbon from the grid. It's really truly about decarbonizing the grid. And while we, our government changes every 4 or 8 years and those priorities change. And right now we have an administration that is hostile to decarbonization, frankly.
Yeah.
And with the exception of nuclear, they're very pro-nuclear, and I have nothing against nuclear per se. What I'm against is the cost, the time to prop those assets up, and the
Yeah.
fact that we haven't dealt with the long-term waste problem. Right now, all of our nuclear waste piles up on site at these facilities, and I live 50 miles from one of them and sail on the lake that was created to build the power plant, and it's a lovely recreational facility for
Hmm.
us. I sail on that lake. It's called
Hmm.
Clinton
Hmm.
Lake, Clinton
Hmm.
Station, a 1
Hmm.
gigawatt nuclear power plant. But all right, it's the final stack piece, and then we're going to have to say goodbye, I'm afraid, but is avoided ignition risk, which is a fairly geographically specific risk.
Yeah.
Fires aren't a
Yeah.
thing in every geography. They're definitely a thing in California. I have not so fond memories of driving on the Highway 5 in San Diego on a sunny day. I used to live in San Diego, and I saw a wildfire jump an 8-lane highway. And
Wow.
it was a very scary thing. And the way I
Yeah.
knew there was a fire jumping the highway, the first thing I noticed was there were cars driving the wrong way on my side of the highway. I was driving
Hmm.
north, and cars started coming south because they had literally just turned around and started fleeing the
Wow.
fire, and
Yeah.
it was quite intense. But how do the utilities in California and other fire-prone areas put a value on avoided fire risk?
Yeah, very, very good question. And you're right that this is pretty specific and pretty localized to those different areas. So, calculating ignition risk is very, very complicated because it's reliant on a lot of different factors. So one is what is the density of vegetation near a power line or near something that can cause an ignition risk? That's number one. Number two, what is the condition of the asset that we're referring to? So are we referring to a bare wire? So there's a lot of actual bare wire in California, in the
Hmm.
Sierras and in places that's close to vegetation. Is it covered conductor? Is it undergrounded? A little bit of that, and then also what are the weather conditions at a given point in time? Because obviously the hot and dry conditions with the Santa Ana winds and how long it's been since the last precipitation, all of those things factor into it. But the way just returning this back to microgrids, one of the ways there's a couple of different ways that utilities like PG&E, for example, have uh, offset their ignition risk. One is they underground full circuits, which is incredibly expensive, but it does reduce the risk down to essentially zero because you just don't have any exposure of causing an ignition there. Another one is through something called a PSPS event, which is called a public safety power shutoff, and that is de-energizing a line to prevent a wildfire ignition. So if there's hot, windy, dry conditions, you turn off a power line, and then therefore that power line's not going to cause an ignition, or the hope is that it's not going to cause an ignition on that part of the circuit or that part of the system. What you can do with a microgrid. So going back to our example with the long substation with a long line to a community that's at the end of it, if that community has the ability to power itself during a public safety power shutoff, then what you're essentially doing is you're reducing the cost or the negative impact of calling that PSPS event. And they have pretty sophisticated logic trees and decision trees for how they do that. And one of it is, okay, are you eliminating power for 50,000 people or are you eliminating power for 500 people? If you're eliminating for 500 people to reduce the ignition risk by the same amount, that might be worth it because the cost and the impact to your customers is much lower. So what we see is microgrids as a tool in combination with those PSPS events to basically reduce the cost of calling one of those events and further reducing ignition risk in those different territories. So really one, like I mentioned before earlier in the call, microgrids really are a Swiss Army knife that can help you with a lot of different circumstances. Those wildfire prone areas and being able to call more of those events to further reduce ignition risk is one of the key use cases that we see along with those other use cases for microgrids that we've talked about before, but really very, very big in the West Coast. And I was here a little bit of a diatribe, but I was here. I actually lived in San Francisco, and I was there when the Santa Rosa fires happened
Hmm.
in the North Bay. So basically, a whole week of not really being able to go outside, wearing a mask and everything, and um, moved to New York City in 2018, and then about 2 years ago, there was really bad wildfires in Canada. So pretty much the same experience that I had in California. Didn't expect to have that same wildfire experience in New York City, but I did. But
Right.
that's, a testament to the, and I know you in Illinois, I know you probably got the Quebec fires
Yep.
down there
For
too.
sure. Yeah.
Um, but that's, another testament to the fact that you can't, when you're looking at these climate risks, if you're looking retrospectively, you're really, really missing what is the actual future risk when you're doing planning and analysis on resilience.
Hey guys, are you a residential solar installer doing light commercial but wanting to scale into large CNI solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much. All right, we're going to leave it there. I want to thank Martin Szczepanik, the Director of Energy Resources at Baringa, for coming on the show and geeking out with me on scaling the rollout of utility microgrids. Check out all of our content at cleanpowerhour.com. Please tell a friend about the show. That's the single most important thing you could do to help others find this content. And with that, Martin, how can our listeners find you?
Yeah, thank you so much, Tim. And this is an absolute blast. Just want to say that first. They could find me on LinkedIn at Martin Szczepanik. If you also go to Baringa.com and search for microgrids, my name will show up with my contact information. And yeah, looking forward to hearing from people and microgrids, VPPs, any other topics that you have. Really just enjoy geeking out. So really appreciate the time, Tim. This is great.
I'm Tim Montague. Let's grow solar and storage. Thanks so much, everybody. The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more.